Alright, welcome to part 2 of Introduction to Electricity. We skimmed a little bit at the end of part 1 about parallel circuits, so let's just review that again. So a parallel circuit is a circuit that contains more than one path for current to flow. If a current is removed, if a component, so the light bulbs here would be the components. If a light bulb is removed or a component is removed, it is still possible for the current to take another path and reach other components. So if I remove the light bulb, this light will still turn on because the current from the battery is still flowing through that circuit. Characteristics of a parallel circuit. The voltage across every parallel component is equal. The total resistance is equal to the reciprocal of the sum of the reciprocal. The sum of all of the currents in each branch is equal to the total current. This is called Kirchhoffs' current law. So let's look at examples. For the parallel circuit shown, we're going to use the laws of circuit theory to calculate the following. We're going to calculate the total resistance, the voltage across each component, the current flowing through each component, and we'll use the results to verify Kirchhoffs' current law. So we're going to look at this parallel circuit, and we know it's parallel because we have our energy source, our battery right here, and we see multiple paths going through resistor 1, 2, and 3. Let's also note that the battery voltage is 15 volts. R1, resistor 1 is 470 ohms, R2 is 2.2 k ohms, and R3 is 3.3 k ohms. So let's find the total resistance. So our total resistance formula looks like this. It's RT equal to 1 divided by 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So we would just plug in those numbers into the formula. We see them here. So 470 and so on. We would get this calculation here. The total resistance is equal to 346.59 ohms. We can round that up to 350 ohms. Now let's find the voltage across each component. So the voltage across each component, when you add them all up, it should equal to 15 volts because the total voltage going through the battery is 15 volts. Okay, let's see what the current through each component is. So using Ohm's law, you can always draw this triangle on a piece of scratch paper, V over IR. So we're looking for resistance. That means we're going to divide V divided by V divided by R. So we're covering the I because we want to look for I. So we're going to do V divided by R, which is Ohm's law. We know we have V1 is going to be 15 volts. R1 is 470 volts. So in order to find the amps, we would divide 15 by 470, which is equal to 31.915. We'll round that up to 32 milliamps. For V2, the second resistor, you do the same thing. I equals V divided by R, which is 15 divided by 2.2, which equals 6.8. We would make that 6.8 milliamps. And so on. V equals, I keep saying V. I mean to say I. So I'm looking for current. I equals the V divided by R, which is 15 volts divided by 3.3, which gives us 4.5 milliamps. Our total current would then be our total resistance, which we got in our last slide. 15 divided by 346 is equal to 43 milliamps. So the current total is 43 milliamps. So if we were to add up all the currents across each component, that'd be 43 43 milliamps, which is the total, is equal to 31 milliamps plus 6.8 plus 4.5. We should get the same number, 43 milliamps. A combination circuit contains both series and parallel arrangements. So let's look at this circuit. What would happen if we remove light 1? And what would happen if you remove light 2 or light 3? If you remove light 1, this whole circuit will not work. If you remove light 2, it would still work. It would just be in series. If you remove light 3, it would still work. It would just be in series. Removing light 1 would open that circuit. Electrical power is directly related to the amount of current and voltage within a system, and power is measured in watts. In order to calculate for power, that would be P is equal to I times V. And here we have a resistor color code chart. Soon you'll be working with electronics and components, and you'll need to pull up charts like this in order to figure out the resistance of a resistor. And you have these color bands. So you would look at the first band, it would give you a value. Look at the second band, it would give you another value, and so on. So if you're looking at this one, we have green, blue, yellow, and gold. So green, let's look at green. So that's 5. And then blue would be 6. And then yellow in the third band is 4. And gold is our multiplier. Let's look at first band, 5. Blue is 6. Second band, third band. The third band is, oh, okay. So our green is 5. And second band is 6. So 5, 6. Our third band in this situation is the multiplier. So that would be times 10. So 56 times 10, 560. And so yeah, this resistor right here is 560 kilo ohms. All right, that is parallel circuits. We're going to get some practice with calculating all those values in some of our assignments coming up.